Okay, the concept behind this problem solving is what we call it conservation of energy, because energy from the spring will be converted 100% to kinetic energy. In order for that box to move and stick together, there's another concept which is called collisions, which is inelastic, because as you can see, after collisions, both of the blocks sticks together, and then eventually it will travels, and then eventually it will slow down and come to rest, and that's due to the worked energy theorem. And also the concept behind this one, you're gonna have to use the Newton law of motion to figure out how much forces acting upon this system. Just make it easy and simple. Just break it down piece by piece. So I'm just gonna go ahead and break it out into this piece first. I'm just gonna go ahead and use this equation that, by now everyone should be familiar with this. 1/2 kx squared is equal to 1/2 velocity mass times velocity square. Replace the number 20 times x squared. But remember, do we know x squared? Yes, we do for this case. 0.2 squared is equal to, what's my mass? Do we know which one we use? We're using only M1 because we're only dealing with this system today before it collides with M2. So do the math, then you do 20 divided by 2, 0.2 square, v squared, that's your velocity square. When you do the math, it's simplified in such a way that it will be square root 0.4, is that, and the answer is 0.63 meter per second, that's your velocity. And this is velocity of M1 before it collides with M2. That's what it is. You need to know what the velocity is for that one. Now we go back to the second part of the equation. So it says after that, these two blocks is right here. Okay, let's draw a picture again about what you know. V2I is equal to 0 because it is at rest. This one, velocity 1I, is equal to that velocity you just calculated that. And after that, it sticks together. So this is the concept of momentum. Pi is equal to Pf. M1 plus M2 times V2 plus M1 M2 times V final square. So now I'm just gonna go ahead and replace the number. This term is 0 because it is at rest. My M1 is 2 times velocity 1 is 0.63, 2 plus 1 Vf. So your final velocity should be 2 divided by 3, 63. That's what your final velocity is. Let's do the math. 2/3 of that. 0.42 meter per second. That's the initial. Okay, this velocity right here, which is the final velocity here, it will become, okay, I'm just gonna say it right here, initial velocity of M1 plus M2 combined. Now we go to the third part of the equations. This is a little bit difficult because you have to use the, so now this is it, right? The whole mass itself is actually 3 kilograms. And moving at initial velocity of 0.42 meters per second. Work over here, and eventually it comes to rest due to the friction force. The mass still 3. It's a solar system. Along the way, there is a friction due to the work, so kinetic. It's actually kinetic friction that does the work to slow it down and all the way until it comes to rest. So now we're gonna use this. This one is equal to force times distance. So we want to figure out how far, you know, the two blocks combined system before it comes to rest. So when we're talking about the force, okay, let's go ahead and let me just go ahead and do this one. Square, okay, is equal to the force times distance. Let me go ahead and show you how we get the force. This is Newton's law of motions. The object itself is on the floor. You have to have a weight which is mg. There's a normal force which is acting upon the object, which is pointing in the opposite direction of the weight. Yes. So over here, the force is actually frictional force, which is equal to mu n. Frictional force is equal to mu, what's n? N is actually mg. This is the frictional force that I'm going to replace it over here. Mu mg times d. Since we have the same mass, I'm just going to go ahead and cancel them out. And you're trying to figure out what the distance is. So I'm just going to divide this one by itself, both sides of the equation. So your distance is equal to 1/2 mu g, velocity square. Let's replace the number. Velocity is 0.42 squared divided by, my mu is 0.1. My g is 10. Then you give me the distance in meters. So now, all we have to do is just plug the values into the calculator. Let me make sure you see my new mg. So what you would do is 0.42 square. That's what you do first. Times 0.5, which is 1/2, divided by. So the answer is this one. Let's double check again to see if you get it right. 0.42 square same. So your distance is 0.088 meter. And that's how you solve for the distance.